Okay, colored pens up. Last time we were together, we explored some pretty challenging equations. We're going to review that now. So what did we get for number 1? Got 1, 2, 3, 4, 5, 6, 7, 8. We'll start with Mia, Valerie, Joali, and then Rashida. What'd you get, Mia? Okay. Okay. I got 3 different answers, Rashida. You agree here, but I got a lot of different answers. Michaela, Chris, and then Gary. That's what you said, Rashida, and Joel? Okay. Negative 11. Someone else said 11 or negative 11. We seem to have the overwhelming support for negative 16. Selena? The correct solution is negative 16. Number 2, very difficult question. What did we get? We'll start with Isabella, Yadesh, Ezekiel. Okay, so we have a disagreement. What do you think? So there seems to be more support for negative 3. Yvonne, what did you get for that one? Seems to be overwhelming support for negative 3. Maybe it's not as difficult as I thought. It's negative 3. Number 3, real-world scenario. What did we get? We'll start with Kianis, Chanel, and then Alex.
I got 9.
9? Okay. 9 months?
9 months.
Yeah, it comes out to exactly 9 months. Number 4 is an FCAT question. It's actually from an old FCAT. And this is a style of question that they like to have you be able to tell which are equivalent equations. And it's really the same thing as solving numbers 1 and number 2, except you don't have to solve the whole thing. You just have to go part way. So which one is equivalent? We got Michael, Michaela, and then up here, and then in the back there. So Michael, go.
I.
You think it's I, okay? You think it's I? Everybody thinks it's I? It is I. So now, here's what we are going to do, a little bit different than what we've done in the past. You've been learning over the last couple of special lessons on my second day how to be a teacher, or at least one aspect of being a teacher, looking for mistakes, trying to understand what was done wrong, and then trying to do it correctly. So now, you're going to do the same thing for yourself. So first of all, let's survey. Give me a thumbs up if you got number 1 correct. Okay, so I got 1, 2, 3, 4, 5 people over here. 1, 2, 3, 4 people over here. 1, 2, 3 people over here. Good. So, put your thumbs down. Give me a thumbs up if you got number 2 correct. There was a lot of people, which I was very surprised at. 5 people over here. 1, 2, 3, 4, 5 people over here. And 1, 2, 3 people over here. Good. So, we're going to focus on numbers 1 and 2. Now your job, you know the correct answer, is you're going to take a minute. And you're going to go back and try and find your mistake. And if you can't find it, you're going to ask one of the people in your column of desks if they can find your mistake or if they can guide you along. So there was 5 people over there was 5 people over here, and there were 3 or 4 people over here. So you got a minute to try and find your own mistake.
I got it going wrong. That's all that. Oh crap, my bad. I'm not.
Really hard. Can I get it out?
They're writing everywhere. That's not the correct.
Very constructive. Very good. Okay.
Oh my God! Very they're writing everywhere on my paper. You live in respawn.
Points for this, but I can't do that. Okay, so come back. Now we're back as a whole group. Back as a whole group. So that actually, I'm extremely proud of my students, and that was really, really good. But I want to make sure everyone gets the understanding that you would like. So, is there anyone who still could not figure out where they went wrong on anything? And see, that's where I'm really impressed with you guys, because everyone was able to find somebody that could say it in a way that actually made sense to them. And that was really great. And I watched and I walked around and I saw a lot of constructive talk about what you were doing. Does anyone have any questions or comments? Go ahead. Number 2? Okay. So number 2 was extremely difficult, and we didn't do any questions like it. But if I add one detail in, it might open your eyes a little bit. If I put that right there, because there is truly a 1 right there, that should change the way you view the problem. If it doesn't, let me go a step further and wipe this out for a moment. So what is really happening is a distributive property. It didn't look like it because it looked a little bit different, but you're in this incredibly high level class, so it's expected that you know that there's a 1 there, and it's really a -1 because of the subtraction sign, and we're distributing it here and here. And so it's a negative 1 times x, which is a negative 1x, and then a negative 1 times a negative 2, which is plus 2. We didn't use this part, and then we really didn't use what was here, so there was a 2x there. And so this is really what we end up with. Was that easy? Of course not. Was it obvious? No way. But with a little bit of thought, you guys can work through complicated equations like this. So Paige, did that open up your eyes to what was really going on? Good. And that was the biggest issue, is that as I walked around, was number 2. Okay? Any other comments or questions? As I said, you guys are doing extremely well. So put the warm-up to the side. For the past few weeks, we've been exploring equations of different levels of complexity. In fact, we started out with simple one-step equations, then we went to two-step equations, which was, we talked about a big leap. Then we made some smaller steps forward by adding in a little complexity. Today is not a giant leap, and today is not a small step. It's more somewhere in between. It's kind of a moderate jump. So today we add complexity by introducing variables on both sides of the equation. So what does that look like? So here are a couple of examples of what I'm talking about. When I say a variable on both sides, I am referring to variables being present on both sides of the equal sign. So in this first example here on the left, I have a 2x on the left, and I have a negative 4x on the right, so I have a variable on the left and the right, and that presents a new challenge for us. The example on the right, I have an 18z on the left, and I have a 32z on the right, and that presents a new challenge. So each lesson, I've been adding new challenges. So this one's a little bit different. And so what we need to do is learn how to deal with it. Now, here's the thing. Everything is a hidden two-step equation. That I've already talked to you about. So we have to just learn how to find the two-step equation that's hidden inside these equations. Okay? So our goal is now to collect all the variables on one side. We cannot solve the equation if there's a variable on both sides. You just can't do it. So we have to find a way to get them all to be on one side. And so that's the new technique that you're going to learn today. The good news is you actually already know what to do. It's just a matter of taking what you already know and putting it in this new context, in this new type of equation. So you may not know what I'm talking about yet. You may have questions. Just hold off for a few minutes, and hopefully it will become pretty clear. So, what we're going to do is use this guide, which is we always transform the side with the smaller coefficient. So I have to demonstrate what I mean by the word transform, and I have to review with you the concept of a coefficient. So that's what we're going to talk about. So I have the same examples just written out again so I can focus on this. A couple of lessons ago, I introduced a phrase that I had written out a bunch of times on my screen. What was that phrase? You remember it? Simplify then solve. And so we always are doing that now because we're not doing simple equations anymore. You always simplify and then solve. And what that means is you look on the left and see if there's anything to simplify. Nope, there's nothing to simplify. I can't do anything here. Simplify the right. Well, there's nothing to do. I'm done simplifying. Now I'm ready to solve. When you're ready to solve, that's when you draw your t. And so now we're at a point where the t is even more important, because it's really important to be able to see the left side and the right side, because now we have a variable on both sides. So let's look at those variables. We've got a 2x, as I said before, and a negative 4x. You can actually start on either side. I'm only telling that to my advanced class, that's you guys. I'm not saying that to any of my other classes. It actually doesn't matter which side you start on, but it will be easier if you do this. If you start with the one with the smaller coefficient, your job will be easier. So, which is the smaller coefficient? Valerie? 2 is smaller. Okay. Oh, we have some reaction to that. Joelle? Negative 4 is what? Smaller than 2? Is smaller? Yeah, negative 4 is smaller. And Valerie, this is the first time we're talking about this, so she may not have known what we were talking about. So first of all, let's clarify the word coefficient. Coefficient is the number in front of the variable. So the coefficient here is 2, the coefficient here is negative 4, and yes, negative 4 is smaller. So we are going to start on the right. So that's our starting point, and it's very simple. Do the inverse. You've been doing that for weeks now. This says minus 4x. Do the inverse. What's the inverse of minus 4x? Keep on. Plus 4x to both sides. So we're going to do this directly underneath. We're going to put plus 4x, and then we're going to do the same thing on the other side, and we're going to write it underneath this x, plus 4x. Now we work down in columns. To refresh your memory about the idea of columns, we've stacked it up. Now that's a column. 2x plus 4x is 6x. Negative 1 and nothing is negative 1. Equal sign. 3 and nothing is 3. Negative 4x and positive 4x are opposites. They cancel each other out. What are we left with? What are we left with? Caesar? Two-step equation. So as I said, everything's a hidden two-step equation. It's just your job to find it. And I truly believe at this point that you should be Jedi Master or beyond. You should be Yoda of two-step equations. At this point, some of you should be able to do it mentally. You could find 6x minus 1 equals 3. You could find that mentally if you really wanted to. But we now know the two steps so fast that we don't even have to worry about it. Okay? Now, I am not going to finish this equation because the purpose here is to introduce the new idea, which is this right here. So we already know this part. We're going to talk about it again in a couple of minutes. Does anyone have any questions about the idea of the smaller coefficient and that being our best starting point? Okay, so let's look at this equation on the right. We simplify and then solve. So I look at the left-hand side and I simplify. Well, there is nothing to simplify. I look at the right-hand side and I simplify. Well, there is nothing to simplify. Which means that we are ready to solve. And that's when we draw our t. Where should we start? Where should we start? Selena and then Rashida. Okay, what do you think? Yeah, because the 18 is smaller than the 32. This should be our starting point. Now, honestly, we'll get the same answer no matter what. We could start here if we wanted to, but this will make your job a little bit easier. So now we do the inverse. This is really plus 18z, so we're going to subtract 18z from both sides. And then we work down. 18z minus 18z cancels each other out. 32z minus 18z, 14z. 12 and nothing is 12. But there's some sort of issue that popped up. What issue popped up as we worked through this? Gary?
There's nothing on the other side.
There's nothing on the other side. I'm not done, so what should I put? 0. That's right. 18z minus 18z is really 0. That was true over here too. Negative 4x plus 4x was really 0, but we don't have to write 3 plus 0. In this equation, we did have to write it because, as Gary said, there was nothing left on that side. If there's nothing left, you have to put the 0. Okay? Does anyone have any questions on how we did that? Comments or concerns? Good, so that's just the introduction, so let's work through some examples formally. And you guys seem to be pretty in tune with what's going on. So we'll probably move at a steady pace. If you get confused or lost, please let me know, and I will try to slow down a little bit. So we are going to solve this equation from beginning to end. So the rule is simplify then solve, and so I want to try and simplify everything before I try to solve it. So I look here on the left, well, there's nothing to simplify. I look here on the right, nothing to simplify, which means I'm ready to solve. So draw a T. And now I need to pick a starting point. Where should I start? Got some light bulbs going off. Where should I start? Gently. Very good. The negative 9x. The negative 9 is smaller than the negative 4, so that's going to be my starting point, and now I need to do the inverse. What's the inverse of that? What's the inverse? Yadesh? Do you agree, Sebastian? Yeah, it's plus 9x. Very good. But we have to do that to both sides. Plus 9x, and again, I'm writing it directly beneath this x. And now we work down. Negative 9x plus 9x cancels out. 15 is left. Negative 70. Now I have negative 4x and 9x. What do I get as a result of that? Danae? Do you agree, Yadesh? Yeah, it's 5x. How many steps do we have left, Chris? Sure? Yeah, we have 2 steps left. You have 2 choices at this point. You can continue with it written like this, or if that makes you a little bit uncomfortable, you could switch this side around so that it was this. This is how we learned to do it. This is the same thing, and you'll get the same answer either way, as long as you follow the rules. So I think we're advanced enough that we can just work from here. But if you feel uncomfortable with that, then switch this around and write it like this. So let's make sure we do feel comfortable with this. What's the next step here? What's the next step? Priyanka? Do you agree, Isabella? That's the next step? Add 70 to both sides. That is absolutely correct. I get 85 equals, this cancels out, and I'm left with this. And what is my final step? Paige? Very good. Divide both sides by 5. This will cancel, and I'm left with x equals, and what do we get for x? What do we get, Selena? Do you agree? Ezekiel? Yeah, it comes out to 17. But I want to make sure I got it right. I've told you this before, and especially with this high-level group here, you will always know if you got the right answer if you check. So if we take the 17 and plug it back in right here and right here, and either do mental math or use a calculator to help ourselves, we should be able to figure out if it's correct. So I can do a -9 times 17. That's -90 and -63. That's -153. Plus 15. So that's -138. -138 on the left. Now do it on the right. So I get a 4 times 17, that's 68. That's -138. So 17 works. I know I got the right answer. In a little while, we're going to do part B, but then after that, we're going to do a checkpoint. Everybody in the room should know whether they got it right or not. You may get it wrong and not know how to get the right answer, but you should know if you are right or wrong before I tell you. We'll get to that in a little while. Does anyone have any questions on part A? Any concerns? So let's up the complexity a little bit because we are so advanced. So I started off by talking about this phrase that I introduced a few lessons ago that Gloria reminded us of, simplify and then solve. And we've been doing it, but we haven't really had to do anything. But now here's a true example of what this means. We simplify everything before we solve. What is this an example of here on the left-hand side? What's that called, Michael? Yeah, that's called distributive property. And so we have to simplify this first before we can solve the equation. So we have 2 times 2x, that's 4x. 2 times a -5, that's -10. Now I've simplified the left. Let's simplify the right. Well, there's nothing to do. Now I am ready to solve. Does anyone have any questions on how we got from that first line to the second line? So now we're ready to solve. When we're ready to solve, that's when we draw our T. And the new idea today is finding our starting point. So what is our starting point for this one? Where should we start off? Michaela, where do you think we should start off? Jen Lee, do you agree? You were going to say -3x? Good. Yeah, because the -3 is smaller than the 4. And I'm very impressed with this group because a lot of you, almost everybody, is really truly seeing that that's a -3 and that's a +4. That's a big leap for a lot of you. So this is our starting point right here, and we need to do the inverse of it. What's the inverse of it? Briante? Kianis, do you agree with that?
Yes.
Yeah, that's good. +3x, add 3x, and work our way down. 4x and 3x, 7x. We didn't do anything with that. We didn't do anything with the 32. That cancels out. How many steps do we have left? How many steps do we have left? Alex?
2.
Yeah, there's 2 steps left. And again, you should be Yoda. So what's the next step? What's the next step? Caesar?
You add 10 on both sides.
Do you agree, Mia? Yep, you sure? Okay. I'll buy that. Add 10 to both sides. That cancels out. We're left with 7x equals, add down, that's 42. What's the final step? What's the final step, Paige? Divide both sides by 7. Some of us could do that mentally. You don't even need to do that final step. 7 times what number equals 42? What's the answer? Janae? 6. Either way, you will get the right answer, but x equals 6. So I'm pretty happy, and I'm trying to model for you guys. You should be feeling good that you got the answer, but now you need to check it. And so this one's even easier to check. If you put a 6 here and a 6 here, 2 times 6 is 12. 12 minus 5, 7. 7 times 2 is 14. Let's see if the other side works. 3 times 6 is 18. 32 minus 18 is also 14. So I know that x equals 6. Does anyone have any questions on how we did that? Concerns? Good. Let's see how we do on our own. Checkpoint number 1. You got 2.5 minutes. If you have only numbers inside the parentheses, you don't have to do distributive. Then you do order of operations. Okay. So for you, you can do that mentally. Okay, so give me a thumbs up if you have an answer that you know for certain is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your thumbs down. Half the class. You now get 30 seconds. 30 seconds, and you're going to take your answer and you're going to check and see if it's the right answer if you have not done so already. My students who already checked, you're going to just be patient for 30 seconds. This is an individual activity. You're not checking with anybody else. You're checking your own. All right, now we're done. Let's see how we did. What is the solution? We got Briante, Rashida, Sebastian, Yadesh, Isabella.
18 equals
Okay?
X equals
Okay? Okay? So all 5 of them agree with each other, and they all seem pretty confident about their answer, and there's a reason for that. Because they checked. X equals 18. Does anyone have any questions or comments about checkpoint number 1? Well, what was your answer? 3.8. Okay, so first of all, did you know that it was wrong? Okay, so that's good. And so I'm not trying to make her feel bad in any way. She knew it was wrong, she just didn't know how to get the right answer. But knowing that you have the wrong answer is a good start. So let's see if we can work through this. So I need some volunteers to help us out. What is the first step that we should have taken? What's the first step we should have taken? So it's just the same 4 people have the confidence? Okay, Isabella, start us off.
You distribute, you do -5 times X and -5 times
Okay, and what she just said was really important. She said you distribute -5 times X. Everyone seems to get that. But the next part is -5 times -4. So -5 times X is -5X. -5 times -4 is, Janae? 20. So we get plus 20 equals -2X minus 34. Okay. So right from the beginning you had gotten a little bit off path. Okay. Do you see now that you have to distribute first? Good. And then from there we follow the steps that we learned. Does anyone have any other comments or questions? Good. So let's continue to build from what we've done already. I'm sorry, build on to whatever we've done so far. So again, one phrase that guides us is simplify then solve. We have to check and make sure everything is simplified before we can actually solve the equation. So what do you notice in this equation that needs to be simplified? Distributive property, very good. So we're going to distribute and distribute. And so now 2 times 4y is 8y. 2 times 5 is 10. So I finished simplifying that. Now check the right. Nothing needs to be simplified. So now we continue. So what should we do next? What's our starting points? Rashida? Okay, why the 8? Why? Well, oh. So because they're both the same? So which one did you do? The one on the left or the one on the right? Whichever one, we'll do the one on the right. Okay, so let's do the one on the right. So we're ready to solve. We draw our t. And since the coefficients are the same, she's suggesting we subtract the one on the right. Well, it's the same thing. And then so this can't, so well wait, this cancels. Oh, wait a minute, and then this cancels. So now I get 10 equals 10.
Y equals 0.
I don't know what just happened. Did I miss something?
Y equals 0.
Did I do something wrong? Okay, hold on. Did I multiply wrong on the left side? 2 times 4 is 8. No, I did that right. You did it right. Okay, so something happened. What happened?
It's the same thing.
What happened, Keegan?
Well, it's the same thing for both sides of the equal sign.
Right.
So it would be y.
You think it's y equals
Y
0?
equals 1.
Well, hold on. Let's check and see if he's right. He's suggesting that y equals 0, so let's check. The way we can prove it is we put a 0 here and put a 0. So hold on. Do the mental math with me. You do it yourself. I'm going to do it. 0, 4 times 0 is 0, plus 5 is 5. 2 times 5 is 10. 8 times 0 is 0 plus 10. So it comes out true. So 0 is the answer. How did he know that? That's
0 plus 0.
Who said that?
so 0 is the solution. Wait, whoa. Whoa, so there's some people making an argument. What did you say?
It could be 1, 2.
It can be 1 as well?
Because 4 plus 5 equals times 2.
Okay, hold on. He's proposing that the answer is actually 1. So let's check it.
0 and 1.
1. Hold on. I want to see this. 4 times 1 is 4. 4 plus 5 is 9 times 2 is 18. 8 times 1 is 8. Well, yeah, that works too. Mia was trying to put into words. What were you saying?
I said, let's just make a proposal, and whatever we put there is going to be the same thing, so just leave it at that.
No, it won't. Wait,
Don't argue.
Okay, I thought you said something. You said something about it being 0 or 1, but okay, I'll move on. Isabella and then Alex. So hold on, Isabella.
It could be any number because I plugged in like 2 different numbers. Like I plugged in 2 and 3, and they're going to come out equal no matter what.
same thing.
Okay, wait. So what? Hold on. So what number did you plug in? 2 and 3. So let's try 2. So let's see if that works. Hold on. I want to see this.
This equation is magic.
I want to see this. You're saying that if I plug in a 2 here, let's try. 4 times 2 is 8. 8 plus 5 is 13. 13 times 2 is 26. 8 times 2 is 16. Plus 10 is 26. So 2 works also. Alex, what numbers did you plug in? 3 and 4? Let's try. Well, wait a minute. I got 3 different answers now. And he's saying he tried 3 and 4, and they both worked also. So that's 5 different answers?
You can go on first.
Caesar, you have something to add?
It can be -1.
It could be -1 also?
Yeah.
Let's try -1. -1 and -1, so that's a -4 plus 5 is 1 times 2 is 2. That's a -8, but that's 2. That works too. So now again, so what? So what happened here? Hold on, guys.
The answer is infinity.
Okay.
Because it's the same equation on both sides, so no matter what number you put in.
Oh. Well, she's actually right, and she said it pretty eloquently, except one correction. It's not equations on both sides, it's the same expression on both sides. And she's right. No matter what number we plug in, it will work. This is a special case. This is a special case where you end up with the same expression. In fact, you can see it right here. 8y plus 10 equals 8y plus 10. We didn't even have to do this. We could have stopped right there because at that point we know that the answer is going to be all numbers. It's all numbers. Don't matter what number.
I said
the answer's infinity, and then you said it right after. Yeah, you did it.
No matter what number you plug in, it will work. It can be, and I like what Caesar did, which was he went and he tried a negative number, because we kept trying positive numbers, and he was thinking to, well, I'm guessing he was thinking to himself, well, wait, maybe it isn't every number, let me try a negative one, and that was pretty smart of him. The next phase would be to try a fraction and a decimal. We don't have to do that, though, because I can tell you that it's going to work no matter what. Every number that we plug in will be a solution. So this is a special case, okay? So it will come up. It's going to come up. Does anyone have any comments or questions about Part A? Yes, Chris? Thank you for the comments. Jed Lee?
Question for you.
Okay, will the F-tab like have a question on both
It absolutely could. Absolutely.
So if you put any of the choices, will it still be correct?
Well, you're saying if it, like all the choices are different numbers? No, one of the choices would be all.
Okay, but what if like the question is like one of those written ones where you have to come up with the number?
It wouldn't be all numbers. Okay? Alright, so now let's try to continue to build. So Part B. So Part B looks pretty similar to Part A. We can see that we have to simplify again, so we're getting pretty used to this. Distribute and distribute. That's a 2 times W, we get 2W. 2 times negative 1, we get minus 1. Equals 2W plus 7. Well, oh, I'm sorry, I made a mistake. I messed up the distributive property. So this was not supposed to be a 1. I'm sorry, I did the distributive property wrong. So this was supposed to be 2. So I apologize. Okay. Back as a whole group now, so I did appreciate the discussion, and that was very productive, and it was really good. Now we're going to come back as a whole group, and then we'll have another opportunity in a few minutes. So we distributed to simplify, and we ended up with this, and we got equals 2W plus 7. So now it's not the same thing. It's different, so we just proceed like we did before. So which side should we start with? Because we're ready to solve. Which side should we start with, Ezekiel? The right, okay. And so what should I start, which term should I start with? Negative 2? Okay. We actually could, and we would end up with the right answer. But we always want to start with the variables if we can. So we got the 2W on the left and the 2W on the right. Which one should we start with? 2W on the left. So this is plus 2W, so we're going to subtract 2W from both sides. This disappears, and now we've got negative 2 equals, and now wait a minute. Well, now that disappeared again. Negative 2 equals 7. So now, something else happened here, but this doesn't look like this one. This came out to 10 equals 10, which is a true statement. But this came out to something strange. This came out to negative 2 equals 7. But that's not true. Negative 2 does not equal 7. So does anyone know what this is called?
No answer.
Yes.
What is this called? House?
Not equal to or not a solution.
Yeah, this is called no solution. In fact, we could prove it. It would take forever. But we could try out numbers just like we did with Part A. We could pick numbers. You could try 1. Plug a 1 in here and see if it works. And it doesn't. And then we could try a 2, and a 3, and a 10, and a 20, and a 50, and a 90, and a negative 1, and a negative 10. and there's no number that will work. None. There's no number that will ever make this equation a true statement. And so what that means is this is no solution. So we actually have two special cases. We have all numbers, which means that no matter what number you pick, it will always be true. Or I could have no solution, which means there's no numbers you could pick. Then the third possibility is, of course, we could actually get a solution, like we did for this one. So we could get a solution, we could have all numbers, or we could have no solution. Does anyone have any questions at this point? Ezekiel?
So if there's two numbers that are the same like that one, then it's going to be all numbers.
Yep.
At the bottom, if with no variable, and at the bottom, there's two different numbers with no variable.
Very good. That was a great way of kind of summing it up. I really like that. And that's exactly right. Okay? Very good. So let's see how well you handle this on your own. Checkpoint number 2. Let's see how you do. You got 2.5 minutes. All right, colored pens up, and let's see how we're doing overall. What did we get? We'll start with Danae, Kevon, Caesar, and then Michael.
All numbers.
All numbers. No solution. Caesar?
All numbers.
All numbers. Infinity. Gloria? All numbers. So there seems to be more people who think it's all numbers. Briante? No solution. More support for that. Garion? All numbers? All numbers. Seem to have a lot of support for all numbers. The correct answer was all numbers. Ooh. I know what you meant. So you meant all numbers, but you don't say infinity because that's a little bit different. Just say all numbers. Okay. Comments, questions on this one? So my students who thought it was no solution, look again, and you should discover that it actually comes out to the exact same expression on both sides. When you simplify the left, you get 4z plus 48. When you simplify the right, which actually takes 2 steps, you get 48 plus 4z. That's the same thing. Okay? Comments or questions?
Why is it 48 plus 14?
Okay, so let me back up. So where did we get the 48 plus 4z? That's a very good question. We have to distribute first. You always distribute first, right? So, Valerie, we have this 40 here that we're not going to use initially. 40 plus, and now we do this. 2 times 4 is 8. 2 times 2z is 4z. But now we have like terms. The 40 and the 8 are like terms, and you have to add them together. And so that's where we get the 48 plus 4z, which is the same thing as on the left. Okay? Thank you for asking. That was a good question. Okay, draw a line across your paper. Your classwork is page 134. You're doing numbers 11, 13, 15, 17, 19, and 21. That's 6 questions. And you've got a little less than 15 minutes. You've got about 13 minutes. Go ahead and get started. Okay, colored pens up, your time is over. Here are the solutions. You mark your answers correct or incorrect. When you get a question wrong, write down the correct answer and then you become the teacher. You try to find your own mistake. Number 11, the answer is positive 9. Number 13 is negative 12. Number 15 was no solution, and it was a tough one. Number 17 was negative 4. 19 is all numbers. And 21 is all numbers. As I said, mark your answers correct or incorrect. If you got something wrong, write down the correct answer, and then you work backwards. See if you can find where you went wrong. Of course, if you can. That's why I'm here, and that's why you have such talented classmates. They might be able to help you as well. So, there were 6 questions. Make a fraction out of 6. 4 out of 6 would be an okay start. Not fantastic, not terrible. It's a pretty average start. Remember, we're just starting with this. By the end of tomorrow, I would expect it to be 75% or higher, hopefully in the 80% range. So give me a thumbs up if you got 67% or higher. Thumbs up if you got 67% or higher. Good, put your thumbs down. Does anyone have any questions on any of them? Isabella, we'll start with you.
Number 13.
Number 13. First of all, what was your solution? Negative 22. Did you know it was wrong?
Yeah.
Okay, if you knew it was wrong, you just couldn't figure out where you went wrong. Give me a thumbs up, everyone, if you got number 13 correct. Good. Joali, what's the first thing you did?
First thing I did was I added, added -5, -11 on both sides.
Well, if you added negative 11 to both sides, then you should have gotten the wrong answer. Negative 11y to both sides, you still should have gotten the wrong answer.
No. I don't know. No, you can get rid of it.
Chris?
That's not positive.
Yeah. So, Joali, I don't know if you're saying it wrong but we're adding 11y. We're doing the inverse. You said you added negative 11 to both sides. We're not adding negative 11. We're adding 11. That's the inverse. So is that what you meant and you were saying it wrong, or you did? Okay. And Chris, that was very good that you picked up that detail. That was important. So this cancels out and we get 32 equals 104 plus 6y. So, Isabella, did you find it already?
Yeah.
What was it?
I put -6.
So you had 32 in the 104, you put -6y, and that's got you all messed up. Okay, very good. Anybody else need to continue this one? Kiana's?
Oh, nothing.
Oh, a different one? Okay.
Number 17.
Number 17. Okay. Did anyone need further steps on number 13? Okay, number 17. Give me a thumbs up if you got number 17 correct. Good, put your thumb down. Valerie, what's the first thing you did?
I added 24.
24s. Very good. So here's the thing. You add 24s to both sides, and that's outstanding, Valerie. This cancels out. Here's a danger zone right here. That's a negative 53, so make sure you wrote down negative 53. That's a 39. What is this when you do negative s plus 24s? Chanel? Close. But we have one negative and 24 positives. Yeah, that's positive 23s. Very good, Chanel. Okay, so you put minus 23s?
No, I didn't really understand how to do it with just the S I put.
You've got the 1. Okay, and that is a common mistake. Okay? So that's just something that takes some experience to get kind of stuck in your head. Okay? Good. We're doing extremely well today. Draw a line across your paper. Your homework is page 133. You're doing numbers 4 through 22 even. And you are having a quiz on 3.1 to 3.3 on Tuesday. As soon as you